Hello everyone, my name is Harrison Charchet.
I'm Sarah Kai.
I'm Caroline Atkinson.
And Rebecca Kellner.
And we're the makers behind BreatheSmart, an add-on device and app for inhalers. Today we're going to start off by giving an overview of our project. Then we're going to go into our design process, speak on the research and development that went into our project, and then finally talk about some of the future directions we hope to accomplish. So first, overview. Everyone meet Joey. Joey's a 6-year-old patient with asthma. Joey's prescribed a pressurized metered dose inhaler, or a PMDI, for both maintenance of his asthma and in the case of an emergency asthma attack. However, Joey doesn't use his inhaler correctly, and the ways in which he does that are very common in other asthma patients as well. So first, he doesn't shake his medication before using it. Second, he doesn't hold his breath in long enough to let the medication disperse throughout his lungs uniformly. And then third, he doesn't breathe through the inhaler at the correct flow rate. Incorrect inhaler use can cause uncontrolled asthma. And for Joey, other asthma patients like myself, this can be a problem of life or death. It not only affects him, it affects his family, his healthcare providers, and the healthcare industry as a whole. Joey's not alone. There are about 51 million people in the United States who have asthma or a similar respiratory disease called COPD, which stands for chronic obstructive pulmonary disease. About 78% of these patients are prescribed PMDIs, which is why the BreatheSmart app and inhaler add-on is for these devices. A study conducted internationally over more than 21 institutions found that up to 9 in 10 asthma patients surveyed use their inhalers incorrectly. And now, this isn't surprising because it was also found that up to 2 in 3 nurses, doctors, and respiratory therapists are unable to adequately describe or perform critical steps for using their inhalers correctly. This can lead to expensive emergency room visits. The annual cost per patient is about $3,000, and the burden on the healthcare system can be estimated over $81 billion. Therefore, our mission for BreatheSmart is to improve asthma treatment by guiding users through proper preventative inhaler use with an innovative yet simple device that users love. BreatheSmart has developed an add-on device, an app to combat inhaler use, therefore. And with that, I'm going to pass it up to Sarah to talk more on our design process.
Great. Thank you, Harry.
So now that you've heard about the common ways that patients tend to misuse their inhalers, I'll be walking you through how BreatheSmart is positioned to target each of these misuse cases. So first, the BreatheSmart app will be instructing patients to shake their inhaler before using it to disperse the medication and prevent it from settling at the bottom of the neck. Second, we'll be continuing to provide guidance throughout the proper inhaler technique steps to ensure that patients are following the proper technique. And finally, we'll be tracking real-time flow rate. And this is really our key value proposition because we're able to track the patient's flow rate while they're using the device and app, and then they can self-correct their behavior to ensure proper drug delivery into their lungs. And thus, they can avoid unnecessary and expensive ER visits. So how did we actually design the device? We came up with 4 main design objectives. First, we aimed for portability. So we didn't want the device to be a further hindrance to using the inhaler itself. Second, we aimed for ease of use. So we wanted our app to be intuitive and easy to follow along with. Third, we wanted our device to accurately and reliably display the patient's flow rate. And finally, we wanted to balance our manufacturing costs with responsible pricing so that anyone with asthma or COPD is able to afford it. In terms of actually achieving each of these objectives, we came up with specific criteria. So first, we found that our device, after several iterations of prototyping, was both compact and lightweight. Second, after testing on a sample size of around 20 patients, we found that 95% of them were able to successfully navigate the app without any additional guidance. Third, most flow rate or peak flow meters, which are the gold standard for flow rate measurement, measure within 10% accuracy, and our device was able to achieve 8.7% error. And finally, we set a maximum of $100 for the cost of production, and the components of our device came down to $76. So to summarize, our objectives for our device were portability, ease of use, accuracy, and low cost, and we were able to achieve all of these. And with that, I'll hand it off to Caroline to talk about R&D.
Thanks, Sarah. So from the beginning, we knew that our device would need to be able to measure flow rate in real time as the patient inhales through our device. So to do this, we started by looking at some fluid flow equations and ultimately decided on using the Bernoulli equation to convert pressure readings from our pressure sensor into velocity. Once we had the velocity of airflow, we could then convert that into volumetric flow rate based on the cross-sectional area of the inhaler. You can see at the bottom right, we have some sample data. You can see a patient's inhalation rate changing over time as they're inhaling through the inhaler. To optimize the placement of our pressure sensor and ensure the most accurate readings, we performed a flow simulation in SolidWorks using physiologically relevant parameters that you would likely see as a patient is inhaling. And you can see in the area indicated in the yellow circle that the flow is fairly uniform across the cross-section and it's pretty stable, which means that we can simply multiply by the cross-sectional area to get volumetric flow rate. And additionally, any small change in movement of the pressure sensor, any change in location wouldn't result in a drastically different change in velocity, whereas down by the mouthpiece, the flow is much less uniform across the cross-section. So the position of the pressure sensor would be very dependent on the pressure reading that it gets. The internal components of our device consist of a microcontroller that's Bluetooth enabled, which allows our device to communicate with our app wirelessly, and additionally a pressure sensor, which we chose based on its sensitivity and its ability to read over the physiologically relevant pressure ranges. Once we had the internal components of our device sorted out, we started designing the external casing and what the patient is actually going to interface with. So we wanted this to be lightweight and compact, and most importantly, we didn't want it to interfere with the use of the inhaler at all. So specifically, the patient still had to have free access to the canister so they could push it down and expel the medication, and the device couldn't impede with their mouth or nose as they're using the inhaler and putting their mouth around the mouthpiece. Additionally, we added ergonomic grips to the outside of the casing, so this makes it much more comfortable to hold and additionally encourages the patients to hold their inhaler in the correct orientation. And finally, we added an external switch which allows patients to easily power our device on and off. Once we had a prototype of our device working, we needed to validate the flow rates and ensure that the rates we were reading were correct. So to do this, we used an airflow transducer and a large syringe, which we could maneuver at a constant rate to produce a known volumetric flow rate. We could read this rate with the transducer and simultaneously read the flow rate from our device. And with this, we were able to compare these two flow rates. So you can see we had very strong correlation between the two. We did ultimately end up with about an 8.7% error, but since we are just reading within a range and telling the patient whether or not they're in that range, that percent error is more than acceptable for our application. So with that, I'm going to hand it off to Rebecca, who will walk you through our app.
Thank you so much, Caroline. So as mentioned, the next step in our process was creating an app. To do this, we created an Android app that we aim to make easy and usable for any patient, basically at any age. So now I'm going to walk you through Harry using both our app and device attached to his inhaler. So upon opening the app, Harry has logged in already, and he has to connect to his specific device over Bluetooth. Once connected, Harry is going to begin to see the instructions. He's going to shake his inhaler, breathe in as hard as he can, exhale as hard as possible. If he wants to do this, he can do it into the inhaler to actually use it as a peak flow meter. Secure his lips, press down, and breathe it in. As you see, we are reading in the inhalation rate, showing him a color bar to say whether he's in the green or good region, and also displaying a message, slow down, speed up, etc. Next, the timer goes off. This is to ensure that Harry holds his breath for the proper amount of time to ensure that the medicine goes completely down into his lungs. Good job, Harry has successfully taken his inhaler. The next thing that we did was we spoke to doctors about what would be useful information to store. Besides for the potential flow rate, besides the flow rates, we created this survey or journal through the help of through speaking to doctors that allowed the patient to enter things like the amount of cardiovascular activity, how they were feeling, stored the location in which they took the inhaler, has the potential to store the weather, the pollen count, and if you see on our CR trends, at the bottom there's the CR trends note, that allows them to look at both their inhalation and exhalation rates in reference to the pollen count, the weather, etc. So how did our device work? So as you see here, we had a patient who did not use our device. they breathed in way too strongly, way too quickly. As you see, they right away went over the 100 liters per minute. However, with our device, they were able to be guided through taking their inhaler to properly maintain the proper flow rate and time frame for proper breathing. So where are we going from here? The first thing we want to do is expand to iOS compatibility. We are already midway and waiting on a few more components. Next, we want to reduce the size of our microcontroller, thereby reducing our entire device by creating a custom microcontroller. Finally, as mentioned by Caroline, we do have an error rate of about 8.7. We do think while this is okay, we would love to get this down to create a more accurate device. And finally, we want to expand our device to work on all inhaler types, thereby just increasing our population size. This again will be done easily either by creating a specific material that can mold to the different devices. We've already been experimenting with silicon, or creating just different models for different devices. So with that, I want to leave you with two messages. One, 90% of people misuse their inhalers, and so many people have inhalers. And two, we at BreatheSmart are ready to combat this problem by providing real-time feedback for the patient so that they can accurately take their inhaler each day and thereby correctly take their medicine and minimize the effects of living with asthma and COPD. With that, I would like to thank you and open up the floor to questions.
In the front.
You know, it wasn't clear to me, how does the device fit on the inhaler, and how does the pressure sensor work?
Sure. So, which slide are you going to? So here the device is external, and it basically slides over the top of the inhaler. So the orange part is our device, and the blue is the inhaler, and it slides down over the top. And then there's a small hole around here that has a tube that connects to the pressure sensor and reads inside of the inhaler, reads the pressure inside of the inhaler. So the sensor and all the electronics are housed in this body, and the tube connects right in the center and reads the internal pressure.
So it just butts up against the...
It goes to the top where it's open.
So there's a hole on the inside.
But I mean, that canister, it doesn't puncture.
No, it doesn't. Yeah. So there's a gap between the canister and this outer plastic casing, and that's where we're measuring the pressure. Yep.
If you're using an emergency inhaler, you kind of take these to boot up the app and stuff. So I'm wondering if you guys have looked at doing this on more than device and what the barriers are.
Yeah, so these PMDI inhalers are used for both maintenance and in the case of an emergency asthma attack. So we realize that like if you're having an emergency asthma attack, you wouldn't necessarily take out your phone, go on your app, and like make sure you're using your inhaler correctly. So we intend to target the people that are using the maintenance inhalers first. And then also in the case of an emergency asthma attack as well, some people can recognize an asthma attack onsetting, and in that case you could probably use it, but we do recognize that.
A future direction would also be to include something like a light, whether it just be one LED, that will just like turn red when you're breathing too quickly. Something very simple that in that case you probably could see.
Yeah, first of all, I think this is brilliant. Second of all, I think that the data you guys collect may end up being more valuable ultimately. And I know you said temperature, pressure, location, all that. Isn't there, I'm wondering if there's some kind of other thing you can collect, like I think there's some kind of wearable, something that can read the oxygen level, the blood, and what about that? And last point, do you require some type of licensing or tools from FDA?
Yeah, good question. I can answer that. So I guess there are two parts to your question. First, you were asking about FDA approval. I guess that was the second half. But we would go through CGMP regulations to ensure that it could be approved by the FDA. We also, in terms of coming up with our objectives, looked at ISO standards specifically for inhalers. And then remind me
The
the
other
first
one
time.
was, is there a wearable you can as well, collecting more data specific to the
Yeah, absolutely. I think that's a great point. At this point, we just wanted to focus on obviously collecting one pressure reading well, but definitely we could expand to different types of sensors. And
Because all insurance companies.
yes.
So let's have me up. Thank you very much.
All right. Thank you.